So here's our first sample question that has to do with solving the equation. You're going to have 3 of these on the test. So we'll start with the basic one. Notice it has an equal sign. It says solve the equation. Equation means you have an equal sign. So this one, I'm not going to try to figure out, can I add these or subtract these fractions? Can I get rid of it? I'm not going to do that. I want to get rid of these things that I don't like. A lot of people hate working with fractions, so let's find a way to get rid of it. And we said the perfect way to get rid of any fractions, as long as you have an equal sign, is to find the LCD and then put the LCD on top of each fraction in the numerator. So how do we find the LCD? Notice that they're all monomials. So you know that you can break down 6 as 2 times 3. 3, it's just a 3. 3, it's just a 3. So your LCD is going to be 2, because that's one type of factor. It doesn't matter that the other ones don't have it. Just got to put down each type, no matter where you find it. And then 3 is your other type. Even though these are duplicates, I only write it down once. Then for 2's, you're going to put in an exponent, the amount. So let's see how many 2's do we need. There's 1 here, 0 here, 0 here. So the largest amount is 1. For 3's, 1 versus 1 versus 1. 1's the largest amount. Most of you probably saw that your LCD is going to be 6, okay? Your common denominator will always be the biggest number or higher. So here we actually got 6. Once you found your LCD, I'm going to use the factored form. And I said put it on top of each of these numerators. But to separate the LCD from the numerator, use parentheses around the numerators first. See how I'm doing that? Then put the LCD right next to it. That way you know what is the LCD versus what is the original numerator. Okay? And then same thing here, 2 and a 3. And then the same thing here, 2 and a 3. I'm using this as my LCD. Now for me to help cross things out, notice we said this 6 is the same thing as 2 times 3. So don't keep 6. Let's write it as the factored form, 2 times 3. The reason why I like to do it that way is so that you can see when we start crossing out for our step 3, is notice that you have a 2 on top and a 2 on the bottom. A 3 on top and a 3 on the bottom. So we can cancel as long as 1 on top matches 1 factor at the bottom. 1 factor on top matches 1 factor at the bottom. And since there's 3 different fractions, we're going to do each fraction separate. For this guy, we have a 3 on top and a 3 on the bottom. And then for this guy, we have a 3 on top and also a 3 at the bottom. So that in the end, your denominators are all gone. Now it looks messy, so I told you the next step is to rewrite the problem as a regular equation problem, no fractions. So here, what's left? Just the parentheses A. What's left here? The minus sign, the 2, and the parentheses 5. Remember, we want to separate the numerator was part of the LCD that was left over. And over here, the equal sign, the 2, and then the binomial, remember, use the parentheses, a minus 4. Once you have that written out, then I told you all you want to do is get rid of those parentheses. Now, how do you get rid of those parentheses? We told you, if there's a number in front, distribute. If you don't see a number in front, slip in a 1. So 1 times A, 1A. Negative 2 times 5 is going to be negative 10. 2 times A, because we're distributing, 2A. And then 2 times negative 4, negative 8. Once you have this, we're going to split it so that you have a left-hand side and a right-hand side. So where the equal sign is, there's your half. On this half, we said collect any like terms, where you know coefficient, variable, constant, no match. Once you're done looking at the left side, let's see if on the right-hand side. Nothing. Remember? Coefficient, variable, constant, no match. Okay, we're not looking on both sides. I don't want you to say constant, constant. We're not there yet. All we're doing is seeing if I could smush this any smaller, see if I could smush this any smaller. Once I realize there's no like terms to collect, or if there were, now's the time I'm going to determine what way am I going to solve. Am I going to do variables on one side, constants the other, or I'm going to do the factoring? We look. No exponents. No exponents here, no exponents here. If one of them had an exponent, like a squared or a cubed, then we have to do the factoring form. All variables on one side, all constants on the same side, the other side has to be 0. But luckily here, no exponents. So I'm going to do our traditional variables on one side, constants on the other. Which side am I going to label the variable? 1a versus 2a. You know, I always choose the side that has the higher coefficient. Once I label this side variable, then default, the other side must be constant. Now I know what things can go and what things need to stay. You know this 10 is a constant, it stays. You know this 1a is a variable, it needs to go. The only way you can move it is the additive inverse. So the opposite of a positive would be a negative 1a. Whatever you do to the left, you have to do to the right. So 2a, negative 1a, hopefully you know that's 1a or just a. Now move over this 8. This 8 doesn't belong on the variable side. So the opposite of a negative 8 would be add 8 to both sides. Their inverses, they cancel out. Negative 10 plus 8, you know a negative and a positive. You know that they cancel. You have to subtract, so that we're going to get a negative 2. So we finally got an answer. But we're not sure if this is a valid answer. How to validate this is look at your original problem, and if you are able to plug in negative 2 in the denominator, and it gives you a 0, then this cannot be an answer. And if this went away, then you would have no solution. But can't plug in for this denominator, can't plug in this denominator, can't plug in this denominator, because none of the denominators had an a in the original problem. So that means this is a valid answer. So for this, we actually solved. We get a equals negative 2. If you did plug in negative 2's where a is, you would get a true statement. So we got our answer.